Alright, I said we were getting more factoring techniques, and we definitely are. We are now on 11.2. We are now going to get the ability to factor trinomials that are of the form x squared plus bx plus c. That is, there's no coefficient here on the x squared yet. Next section, we will be able to deal with things that have a coefficient on the x squared. But for now, we have the form x squared plus bx plus c. Let's just look at an example. When I say I want to factor this, that means I want to be able to write it as the product of two smaller polynomials. In this case, and we'll look at y later, both of those are going to be of the form x plus something. Now I don't know what those somethings are. For the moment, let's call this one triangle and this one square. I want to be able to write my x squared plus 9x plus 18 as x plus triangle times x plus square for some values of triangle and square. In order to figure out what those are, let's multiply this out. These are two binomials. We'll use the FOIL method. When I multiply my first term by my first term, that's x times x, that's x squared. When I multiply my outside terms, I have x times square. So I'll add square x. My inside terms, x times triangle, plus triangle x. And my last terms, triangle times square, plus triangle square. Now I'm going to write that a little bit differently by undoing my distribution. That's x squared plus square plus triangle times x plus triangle square. So, my x squared has no coefficient. My x has a coefficient. It's squared plus triangle. I need my x coefficient to be 9. That means square plus triangle equals 9. Then I need my constant coefficient to be triangle square. My constant coefficient is 18. So I know 18, I'll write it in the same order. Square triangle equals 18. So I need to find two numbers that I can add and get this x coefficient number, and that I can multiply and get this constant number. Alright, let's think of all of the numbers that I can multiply and get 18. 18 is divisible by 1, so I could have 1 and 18. I could have 2 and 9. It's divisible by 3, 2, 3 and 6. Does 18 have other factors? Oh, I think that's all of them. So I need to think which of these pairs adds up to 9. 1 plus 18, that's 19, not 9. 9 plus 2, that's 11, not 9. 3 plus 6, there we go. So triangle and square are 3 and 6. So when I factor my polynomial, I have x plus 3 times x plus 6. Now, as soon as you have factored a polynomial, always multiply it out and make sure you get back where you were. This will help catch a lot of errors. If I multiply that out, I've got x squared plus 6x plus 3x plus 18. That is, in fact, x squared plus 9x plus 18, so I'm good. I successfully factored my trinomial. But what made this easier in this case was that both of these signs were addition. The fact that both of those signs were addition meant that I immediately knew that I had x plus in both of my binomials that I was trying to factor it into. What if I had something like this? if I try and write an x plus times x plus, I'm never going to succeed, right? No matter what numbers I plug in for square and triangle, when I multiply them out, I'm never going to get something with a negative here. So I need a different technique. Let's make some rules. All of our polynomials, we're going to think of them as being of the form x squared plus bx plus c. So we can talk about what b and c are now. If c is positive, then I know that both of my factors have the same sign. So I either have x plus times x plus, or I have x minus something times x minus something. If b is also positive, then my sign is plus. That means I'm in this situation. If b is negative, then I'm in this situation. So let's look back here. Our b is negative. So if b is negative, we're here. So I have x minus times x minus. But nothing has really changed about our system. I still know that I need these numbers to be two numbers that I can multiply and get the thing in the middle, and add and get the thing at the end. But I'm going to think of that minus sign as being a part of these numbers. So I want two numbers that multiply to that constant term, which is plus 8, and add to that x coefficient, which is negative 6. I know that both of these numbers are negative. Right? Because I said that this minus sign was a part of those numbers. So I have x plus each of these numbers, and the numbers just happen to be negative. Okay? So I can think of all of the numbers I can multiply and get 8. 8 and 1, 4 and 2. That's pretty much it. Now let's think of all of those being negative. 8 and negative 1, negative 4, negative 2, because I know I'm looking for a pair of negative numbers. If I take negative 8 and add negative 1, I have negative 9. That's not negative 6. If I take negative 4 and negative 2 and add them, I have negative 6. So I'm perfect. If I factor my polynomial, I'll get x minus 4 times x minus 2. I can check. I can multiply that out. That's x squared minus 2x minus 4x plus 8. That's exactly what I wanted it to be. So we've done 2 examples. In each of them, c was negative, but we changed the sign of b. Sorry, in each of them, c was positive, but we changed the sign of b. But we need to think about what happens if c is negative. Then each factor has a different sign. So I have something like x plus something times x minus something. That is, I know that when I'm looking for my two numbers, one of them will be positive and one of them will be negative. And I get to choose which one's which to get my addition relationship that I need. So let's look at this one. I know that I need two numbers that multiply to minus 8 and add to minus 2. So I know one's positive and one's negative. Let's think about all of my choices. Maybe I have -1 and +8. Maybe I have +1 and -8. Maybe I have +2 and -4. And maybe I have -2 and +4. I can check all of these, see what adds up to -2. -1 plus 8, that's 7, not -2. -1 plus -8, and -7, also not -2. 2 plus -4, that's -2. I can check the last one. -2 plus 4 is +2, not -2. So I know my two numbers are 2 and -4. So I have x plus 2 times x minus 4. I check that. X squared plus 2x minus 4x minus 8. Perfect. That's x squared minus 2x minus 8. Okay? So whatever the signs are on my B and my C, I have the same technique for factoring it. I find two numbers that multiply to my constant term, whatever its sign, and that add to my x coefficient, whatever its sign. Okay? The last thing we want to mention is that it is absolutely not true that every polynomial is factorable. So I could have something like x squared plus x plus 20. I'm then looking for two numbers that they're both positive, since both of these signs are positive. Multiply to 20 and add to 1. Certainly no such two numbers exist, so that's not factorable. Okay? We still have more factoring techniques to learn, but we're making real progress.